That rock here with Simpson math. We've been using the quadratic formula to help us find the x-intercepts of parabolas and then graph the parabola. Let's back up a little bit, talk about the basic parabola, and then do some transformations of that basic parabola. Okay? So what I have here is what is often called the parent parabola, or the parent function that's quadratic. So it's just simply y equals x squared. So notice there's no linear term and no constant. If there's no constant, then that means the constant is 0, so it crosses the y-axis at 0. And there's no linear term, so b is also 0. And our leading coefficient, or a, is 1. And if we just look at a table of values, we know that if we square -2, we get -2 times -2, which is 4. And -1 squared will be 1, and 0 squared is 0, and 1 squared is 1, and 2 squared is 4. And we plot those points, and we get this nice parent parabola. But what I want to talk about is what's called transformations of the parent parabola. One thing you can do is translate them. Translate's a fancy word for shift it. Just slide it up, slide it down, slide it left, slide it right. Just move it in the plane. So it doesn't actually change shape, it just moves. One way to do that would be to say, maybe add 1. What if the equation was x squared plus 1? Can we see that? Maybe I need to blow up a little bit. What if the equation was x squared plus 1 instead of just x squared? Well, you would still put -2 in and square it. So we would have -2 squared, and then the plus 1's on the outside, so we get 4 again, just like we got last time, but now it'd become 5. So, in other words, all of the y values would go up 1. And so the graph lifts up 1. 0, instead of 0, 0, there's a point at 0, 1. So 0, 0 becomes 0, 1. 1, 1 becomes 1, 2. -1, 1 becomes -1, 2. This point comes up to 5. The point at 2, 4 goes up, is now 2, 5. And the parabola looks like so. So notice, it just lifted up 1 unit. That's called a translation. You can translate by shifting up a set amount, going down a set amount. You can go left and right. Left and right's kind of tricky. Let's think about, let me come over here and get a new plane. Let's look at our basic parabola again. -2, -1, 0, 1, 2. If I look at just x squared, well, I get 4, 1, 0, 1, 4. But what if I looked at adding 1 first? Or let's add 2. Let's add 2. What if I added 2 first, then squared? So I add 2 to the input, and then I square. So the formula looks like this, which of course, if we follow this out, we get a trinomial. Let's see, that would be 4x plus 4. Because remember, x plus 2 squared is x plus 2 times x plus 2. So your x times x gives you x squared. You get a 2x and a 2x, which gives you the 4x. And then 2 times 2 is 4. So, but if I add 2 to the inside, what happens? Well, I put the -2 in. I get -2 plus 2. And that becomes 0 squared. And so I just get 0. So notice I got this point, but I got it when I got -2. So what does that mean is happening? Let's look at the graph. So the base graph goes through this point, that's 1, 1. Here's a -1, 1. At -2, it goes through 4. 1, 2, 3, 4. And this is, so here's the parent parabola. Y equals x squared. But notice when I add the 2, I should have done this in some color. Let's do yellow. So when I added the 2 first and then squared, then when I put in -2, I got out 0. So now all of a sudden, when I put in -2, I get out 0. Hey, this point seems to have moved here. Does that happen every time? Well, let's try it. So when I put in -2, I got 0. What happens if I put in a -1? A -1 plus 2 squared, of course, would be 1 squared, which is 1. So when I put in -1, I get 1. So -1 is 1. So did that point just stay here, or did this point slide over? Oh, let's try -3. Let's move over to -3. Let's put -3 into the function. I haven't done that one yet. If I put -3 plus 1, I get a -1, which when I square, I get 1. Okay, so we see that when you put in -3, you get out 1 also. So it looks like this point moved 2 to the left, and this point moved 2 to the left. And so the parabola seems to have just shifted 2 units to the left. Now that seems a little odd. We added, so normally positive means right and negative means left. But it turns out whenever you have operations inside the main operation, so we're squaring, but we added inside that square, it's the opposite of what you might think it would be. Instead of going to the right, it actually went to the left. Some of my students remember that by saying exes are liars. Their ex-boyfriend or girlfriend was a liar, so their exes are liar. If you're in here affecting the x first before you square, it lies to you. It makes you think you should go right because it's plus, but it goes left. But anyway, these were 2 examples of translating the parabola, which means shifting. You can shift up, you can shift down by subtracting, you can shift left and right by adding or subtracting on the inside. You can also reflect. What if let's get a new table out. What if I put a negative out here? So that when I put in -2, that means I have negative of -2 squared. This negative is there, and that negative is inside. Well, that would give me a negative of 4, because this -2 times -2 is 4, but that's still a negative. So notice, normally when I put in -2, I got a positive 4, but now I put in a -2, and I had that negative on the outside, it went to -4. So -1 would be negative of -1 squared, which is positive 1 here, but this negative is still there. 0 is not going to matter, because 0 squared is 0, and the opposite of 0 is still 0. 1, that gives me 1 squared, which is 1, but the negative is still out front. And then 2 gives me 2 squared with the negative out front, which gives me 4, but the negative's out front, it's negative. So all of the y values except 0 change sign. 0 doesn't, it doesn't have a sign. So what happened to the graph? Well, it's still going through 0, 0, but at -2, it went to -4. And at -1, it went to -1. And at +1, it was -1, and 2, it was -4. Can we see all that? Yes, we can. So the parabola is now here. And notice it's a mirror image of the original parent parabola. We call it a reflection because it's a mirror image, and it's using the x-axis as the mirror. So whereas let me put it in ghost, the original parabola had a point here and here. It was 1 unit up from the x-axis, so there's a mirror image 1 unit down. So when you put a negative on the outside, that's what happens. If I put a negative on the inside, then it reflects left, right, instead of up, down. So just like shifts when you add or subtract on the inside, you move left and right, and you add and subtract on the outside, you go up and down. Well, if I multiply by a negative on the outside, I reflect up, down over the x-axis. But if I put a negative on the inside of the operation of the square, then it will reflect left and right over the y-axis. Something kind of interesting happens with a parabola when you do that. So let's look at that right quick. So I have the negative on the inside, and I'm expecting it to reflect. If it was another graph, like a line, it would reflect over the y-axis. It would create a mirror image on the other side of the y-axis. But notice here, if I put a -2 in, this -2 is there, and then this negative is there. So I have a negative inside the parentheses. I got to take that double negative inside the parentheses I have to take care of first. That double negative becomes a +2. Squared is 4. I get the same value out. Why is that? Well, let's look at the regular graph. So the regular graph at 0 is 0, at 1 is 1, at -1 is 1, at -2 is 4, 1, 2, 3, 4, and at +2 is 4, and it looks like this. Well, if I try to create a mirror image of this point, let's make sure we can see that. So this point is 2 units from the y-axis. If I try to create a mirror image of that point, so I have to go 2 units on the other side of the y-axis. And look, there's a point there already. If I try to create a mirror image of this point, it's 1 unit to the left of the mirror. So if I go 1 unit to the right, oh, there's a point there already. So sometimes when you reflect, you don't change the graph. If you reflect left and right and you don't change the graph, if you reflect left and right over the y-axis and you don't change the graph, it's a very special type of graph called an even function. And any function where you put in a negative, you simplify and you get the original function out, is called an even function. So the quadratic, that is, doesn't have a linear term. If I had a +2x here, this is not linear. Because if I put a negative here, it changes it. This would become a -2. So that's not even. But this quadratic, the parent quadratic, is an even function. Okay, we've talked about translations and reflections, and we've learned how to slide the graph around without changing the shape, and we've learned how to reflect it over the x and y axis without changing its shape. Math made simple, Simpson Man.